So, what I'm aiming to convey today is that as enterprise developers, and given that most of you have used Spring, I'm assuming you are mostly enterprise developers have a really important role in making GenAI usable. GenAI is a very real thing. It's not going to go away, but it is something that is extremely difficult to use in business applications. So, the importance is uncontestable, but you read a vast number of blog posts that are very, very far removed from reality. So what I want to talk about is how hopefully all of us in this room can use the skills we have to get closer to reality. So I want to show some of the core concepts of building or GenAI applications or GenAI enabling existing applications. I want to show that you can do this in the JVM and that the JVM is competitive with Python for building GenAI apps. And also I want to show you both some of what I consider to be best practices and also some of the challenges. But before we get there, let's think about Spring. Spring has been around for a very long time. I have the beach ball of death. This is not good, okay. Spring has been around for a very long time. It, in fact, dates back to the beginning of this century. Yet it's still around and it's still thriving. Let's think about why that is. And I think there's really three fundamental reasons. One is that the Spring team is awesome. And certainly, one of the things that I'm most proud of in my career is that I assembled the genesis of that team, which has continued to be involved in Spring and led Spring for decades. The Spring community is awesome, and that obviously overlaps with the Spring team because the Spring team is part of the Spring community and comes out of the Spring community. But thirdly, Spring is built on some very solid core concepts. And those core concepts have stood up incredibly well over 2 decades. So if any of you have been involved in the Spring community since the beginning, you'll probably remember something that we used to talk about called the Spring Triangle. That was the 3 key ideas that have always been core to Spring. They are dependency injection, portable service abstractions, and aspect-oriented programming. Dependency injection is obviously how Spring components get to know about each other and get to know about infrastructure. Portable service abstractions are how Spring apps can work with underlying resources and capabilities. For example, one of the first killer things that Spring did was enable you to write an application that could provide transactions either in, say, a Tomcat environment or a WebSphere, WebLogic distributed transaction environment. AOP enables you to combine those 2 things. So for example, if you're using Spring, you've probably used or seen the transaction interceptor where you have @transactional annotations on your methods. That is enabled with Spring AOP, which intercepts calls to those methods and applies transaction management. So it turns out that these 3 core concepts have been a gift that is kept giving for decades, and it turns out that, as hopefully I'll be able to convince you, they are extremely powerful and suited to dealing with the challenges of building GenAI applications. If you've thought about GenAI or worked with it, there's a pretty high probability that you've used Python. Certainly, there is undoubtedly a Python affinity in machine learning. And it has reached the point where I truly believe that every developer needs to know Python. I think it is the one language that every developer is going to need to know. So if you're not already fluent in Python, I would strongly encourage you to get fluent because I really think that's important. And by getting fluent, I also mean getting fluent in current Python. Python has improved a whole lot in the last few years. If you look at, say, 3.12, it has kind of like a type system. Type hints are really quite good. It's certainly way better than Python 2, incomparably better than Python 2, and it's even significantly better than early Python 3. So I would say, as a just side piece of advice, you should know Python. You should be able to read it. However, that is absolutely not the same thing as saying that you should be building applications in Python rather than Java or .NET or whatever else you're using. I think it's important to be able to read Python and write Python because there is a lot of work in machine learning and GenAI that's done in Python, and if you want to keep up with all the experiments that people are doing, it's really important to be fluent. But I really believe that if you're building enterprise applications that need GenAI, you're better to stick with the stack that you're presently using and the GenAI capabilities that are now growing on that stack. So in this presentation, I'm going to do live coding using Spring AI, and you'll be able to see that Java or Kotlin or whatever language you use on the JVM is really quite competitive now in GenAI. Okay, now we get to the exciting point where this demo is cursed. I have given this talk, or a variant of this talk, twice before. Each time has been accompanied by disasters. And clearly, the internet not working, one talk that I gave in San Francisco, 3 wireless mics ran out of battery while I was trying to talk. This time our challenge is the beach ball of death. So, yep, IntelliJ is really dead. Okay, so, yep, it's just IntelliJ. Okay, let us try force quit. Yep, it's IntelliJ. Okay, interesting. Well, if I can get IntelliJ up, we will get to look at, whoa, okay. This is what it was doing this morning when I couldn't work out why IntelliJ was not, it just started and minimized itself. I tried rebooting this morning, it didn't fix this problem. Unfortunately, I don't remember what did fix it. I had this exact problem this morning. What if I... Has anyone seen this where... Whoa, okay, that's fascinating. Okay, so we have IntelliJ up. So what I have started by doing is creating a new Spring Boot app, and I did that by going to start.spring.io. So with the Spring initializer, you can see on the right the packages that I took, OpenAI, Ollama, which are from Spring AI, the Neo4j vector database, Spring Data Neo4j, and the Spring Boot actuator. So, by the way, the project that I have is on my GitHub. So Johnson R is my GitHub ID, and this repo is currently pinned as Spring AI demo. So very important to know that if IntelliJ crashes completely, you can still actually get to see the code. But I will endeavor to show you some of the code now. So what I'm going to do is build a simple chatbot and demonstrate how we go about this in Java. So the first thing that we need to do is have fundamental kind of table stake setup. So there are 2 core concepts that Spring AI has in accessing GenAI models. One is called a chat model, which is essentially an LLM, like one of the OpenAI LLMs, like GPT-4. The other is an embedding model. Embedding models are used for vector similarity search, and they are a very important part of the whole setup. So you can get your chat model set up using Spring AI as simply by importing a starter. So if you import a Spring Boot starter for OpenAI, you will automatically get a chat model. In this case, one of the things that I want to show is that you can use more than one chat model in the same application. So I'm explicitly configuring it. So I am explicitly configuring it using a Spring at configuration class. And you can see here I've got two chat model beans. I've given them separate names, but you can see that I've used the primary annotation on one of them. So if I just inject the chat model anywhere, I get the default chat model. So the default chat model is the default OpenAI chat model, which I think is GPT-4o currently in Spring AI. But I've also set up a local chat model, which is an Ollama chat model. Has anybody used Ollama, O-L-L-A-M-A? Ollama is a very cool open source project that enables you to work with open source models, potentially locally. So there's been really a lot of evolution in the world of LLMs in the last year. Say 18 months ago, even 12 months ago, open source models were not, that you could run on your local machine, were not a whole lot of use for most things. Now they are definitely quite usable for certain things. And that's kind of a game changer. Because remember, if you look at the, at the resources consumed by models like GPT-4, they are so inconceivably massive that your laptop can't, not only could it not possibly do training or fine-tuning, it can't remotely do inference. And it also means, of course, that these big models have a very high environmental footprint. They use a lot of electricity and they use a lot of water. So, one of the things that I would say in terms of best practice is use the smallest chat model that you can use for any purpose. That gives you two benefits. One is it means that the planet might last a little bit longer, but secondly, it means that you have more ability to explain what's happening. Let's suppose that, in theory, big models were able to eventually do anything we wanted to do. That would still be pretty scary for a business application. Why was a particular response generated? I don't know, there's 1.2 trillion parameters in the model. Clearly some combination of them said this is the response we should have. That's really not adequate. So if you can think of your applications in terms of potentially breaking them up into smaller interactions, you have a greater ability to explain. So, unfortunately, to the best of our knowledge at this point, LLMs are probably always going to be black boxes. Neural networks have always been black boxes. But there's a difference between an application that's wholly reliant on a giant black box and an application that uses a number of much smaller black boxes and potentially makes decisions between the invocations. So, remember the spring triangle. Which parts of the spring triangle are relevant to using multiple LLMs? Well, there's clearly two. One is the portable service abstractions. So when we inject these things, the chat model interface will be the same. So we will get a high degree of portability between these different things. That is something the framework provides for us. Another thing, of course, that is relevant is dependency injection. We're going to be able to inject our chat models. Here, of course, I should say that getting portability between LLMs and embedding models is not unique to Spring. Obviously, this is something that Python frameworks like LangChain and Llama Index have done for some time. There's also LangChain for J. But the point I would make is that naturally you would expect Spring AI to do it, and it now does it very, very well. So portable service abstractions, we've got that. Now we have set up our configuration, we can inject chat models. So here is our application. It's just a very straightforward Spring Boot application. The most interesting thing is the chat service. Chat service uses something called a conversation session, which is a session scope component Not particularly relevant to GenAI, but just an example of how, if you're building this app, you can use all the things that are given for you in the Spring framework, like transparent management of conversation sessions. This is the most interesting thing. So here we have simply injected our chat model. Which chat model do we get when we inject the chat model? By default, we get the primary one. I've also injected an Ollama chat model. In the next milestone of Spring AI, there's some really nice stuff that is going to be available around injecting multiple chat models, but in this case, I'm differentiating them by the type. I could also differentiate by using an at qualifier annotation. So once I've got a chat model, I can build a number of chat clients. So the way to think about this in Spring AI concepts is you have your provider like Ollama or OpenAI, and you have one or more, very often one, chat model that talks to a particular model from that provider. And that takes care of the low-level transport, right? The core connectivity. However, when you use that chat model in a particular application context, you may want to use a different system prompt, for example. You may want to have different observability, different interactions in the use of that model. So that is where the chat client sits as a higher level concept. So you can typically have one chat model and a number of chat clients. So chat clients typically use a system prompt. In this case, the system prompt comes from systemprompt.md. And what this does is set up the basis of every interaction. So the messages that will be exchanged in a conversation typically start with a system prompt and then are an exchange of user messages and assistant messages. An assistant message is a response from a chatbot, and the system prompt sets up the whole conversation. So in this case, the system prompt says that the chatbot's a helpful assistant working for Classical Music Emporium, and it helps users discover classical music and learn about composers. Okay, let's run this and see what it does. So we will start it up. And oh dear, the zombie one, see, demo. The zombie one is still using that port from the previous. Oh God, how do I kill? Oh. I've got to kill whatever's on port 80. You know what? There is an easy command for this, but we're just going to totally avoid that, and we're going to do this. So our demo is now on port 8081. No, oh, there's another one on 81, seriously. See, I said this demo is cursed. What? 8083 cannot be in use. Okay, I have absolutely no idea what is going on here. I have never put anything in my life on port 8087, so if this is not going to start up, okay. There is nothing on 8087. Oh, what is that? Oh, there is something on 8087. Okay. Okay, 8094. This is, well, this is going to be fun. We've got to find something somewhere. $1994. Sounds like a good pot. How can this be running on every single port? I am utterly baffled. Okay, we're going to work backwards. We're going to find, right, 3000, which is normally used by Node. I'm not running any Node projects, so let's be sneaky. Let's get in here. Okay. Okay, let's see if it's any better if I run it this way. I have absolutely no idea how to... yeah, it is, but what started it? I think this has to be IntelliJ. Okay, I'm going to quit IntelliJ, and it will presumably kill all these. Yes, thank you. That is the one that I can never remember. Okay, so now we're going to go back to, well, let's go back to 8080. 8080, okay, actuator health endpoint's not up. Nothing's up. Okay, let's try. Come on. It has to be IntelliJ doing something evil. Now 8080 is there, but IntelliJ has died. Okay, I'm going to use, 8081. Okay, I'm going to use 8081, and I'm not going to use IntelliJ. I'm going to use the Spring Boot run. Okay, so... I'm sorry, I have absolutely no idea what's happening. I think it has to be IntelliJ, but exactly what it's doing, I don't know. So 8082, okay, so well, we're just going to go through all ports in turn and hope we can actually show you something. So we're going to, if this comes up, well, there'll be something on 8082. As we burn each port, something's on 8082. So let's have a look at it. Okay, so who are you? So this is going to go to the chat model in the sky, and you can see that it has used the system prompt. So it's a helpful assistant. So now let's ask it, does your business have physical stores? So what happens when an LLM doesn't know the answer? So there are two things that can happen. Yes, it can either say it doesn't know the answer, or it can just make it up. In this case, it kind of made it up. I mean, it's quite possible that could be right, but it is clearly not something we can depend upon in our applications. So the system prompt did succeed in that it helped us, direct the user towards interactions around classical music, but it didn't succeed in grounding the response in anything sensible. So if we wanted to answer questions, we need to change our chat service, and we need to essentially provide what is called Retrieval Augmented Generation. Retrieval Augmented Generation is a core technique for avoiding hallucinations. So what this means is that when we are asked a question, we look up the materials that might be relevant to answering that question. How do we do that? So clearly we've got to have a database that is storing potentially relevant materials, and secondly, we have to have a strategy for querying that database. The normal data store that we use is a vector database, and the way this works is we've taken a lot of content, for example, text content. We have embedded that content, so we've done vector indexing. So each chunk of content in the database has a vector associated with it. And when a question is asked, or we need to find something relevant to a conversation, we go to that database and say, what do you think is the most similar content that is relevant to answering this question? So the way in which I've enabled this involves two things. The first thing is that we put a question answer advisor in. This is something that comes from Spring AI, and Spring AI gives us a simple, out-of-the-box implementation of Retrieval Augmented Generation. So what this does is actually behind the scenes it's going to edit our prompt to include this. So the user message will be extended by adding this. So what this question answer advisor will do is go to the VectorStore, say what is most similar to what the user asked, put it in here, and then the model may be able to answer the question. Obviously, we needed a VectorStore as well. If you recall, in the way we set this up, we use the Spring AI Neo VectorStore starter. So again, we come back to portable service abstractions. Spring AI supports pretty much all the popular vector stores. There are two fundamental schools of thought on vector stores. One is that you use a dedicated vector store like Pinecone. Another is that you use the vector capabilities that are being added to pretty much every database. So in this case, because I'm using Neo4j for other things, I'm using Neo4j's vector capabilities, which are quite good. If you are, for example, using Postgres, PG Vector is really, really very good. So for example, if you're using a Spring JPA application using Postgres, your first instinct should be to use PG Vector and add vector capabilities to Postgres. So we're going to restart this, and this is truly exciting because I have absolutely no idea what's going to happen. So we have, well actually I'm pretty sure it's going to fail. Okay, so we're only used port 8082. Let's go to 8083. Mind you, it shows you how easy it is to configure Spring applications. So we restart this, go to 8083, and hopefully it's the right 8083. We have in some setup code which you can find in the repo. You can see that I have indexed some existing documentation, so this tells us about the stores. So we've put in a little bit of data that hopefully will make this work. Do you have physical stores? So, very different response. We have been able to ground the response in solid fact in this case. So that's one of the fundamental techniques of making LLMs useful in production. And as you can see, it was very easy to set up basic RAG using Spring AI. If we go back to the chat service, you can see the way I configured this. So we've got default advisors, which include the message chat memory advisor, which is where we store all the messages, and that, as you would expect in Spring, is pluggable, portable service abstractions. And we have the question answer advisor. Anybody remember the term advisor? It's an AOP term, isn't it? So this is essentially an application of AOP concepts to chat. So the advisors are essentially a pipeline of interceptors that are involved in generating chat responses. Okay, let's have a look at what else we could do with advisors. Remember, what is AOP good for? AOP is good for addressing cross-cutting concerns. AOP is also good for having really, really off-putting terminology, like join point and cross-cutting concerns. But essentially what AOP enables us to do is to apply consistent behavior across multiple things. So for example, transaction management. What kind of consistent behavior might we like to apply across multiple chat interactions? Well, one pretty obvious one is a toxicity guard, right? If we want to guard against prompt injection, guard against toxic interactions, that's a very obvious example. And it means that you potentially have the ability to build components that are reusable across multiple applications. Okay, now let us build I'll show you a advisor that is not out of the box, which is one that I have authored myself. So let's have a look here at the topic guard. So I hasten to point out that this is not something that is production grade, it's just an illustration. And what I'm going to do is guard against unpleasant or irrelevant topics. So in order to do that, we need to classify the topic that the user seems to be talking about. How are we going to do that? We're going to use another LLM. We could, of course, use a much smaller model for a classification model, but in this case, we're using the local LLM. So here, when we create this, we're giving it a chat model in the constructor, and we're going to classify the topics. Very simple. Kotlin data class, as you can see. I'm using Kotlin rather than Java. I do find Kotlin an extremely pleasant language to work in, and it works brilliantly with Spring. But you could write this in Java and it would work exactly the same way. So we're going to classify the topic, and the topics that we have are sport, religion, politics, or other. And I think, as you can guess, we probably don't want to talk about politics or religion. So to do the actual classification, we will use a different chat client. Remember I said that chat clients are kind of essentially lighter weight than chat models. We can have multiple chat clients. In this case, we're going to use a quite different prompt, which is topic guard, which looks like this. There's a couple of things that are different about this prompt to the other one. One is that I happen to use a convention of XML-like convention to delimit the content. It's usually a good idea to try to be very clear about what things are being assessed versus what is kind of system prompt. Doesn't need to be XML style, but this concept of delimiting something that should be assessed by the model is important. And also notice here that we've got curly brackets, so this is actually a template. It's not going to be a literal string. We're going to replace that dynamically with a value that we have at runtime. So in this case, we're using the default out-of-the-box prompt template syntax which Spring AI provides, which is compatible with Python f-strings. This makes sense because Python is obviously, as I mentioned, a very popular language in the world of GenAI. The next milestone of Spring AI is going to probably have additional prompt templates like possibly Ginger and Moustache, so additional templating technologies. So here we've also set a parameter to say that the user content is going to be passed to that. But we've done something quite different here. Remember that this interaction is not about generating a response to the user. This interaction is about returning a JVM object. This interaction is about returning this object. Turns out that particularly when you're building business applications, a lot of the interactions that you have with LLMs are not just generating free text. They're generating structured output. Again, this is the kind of thing you would expect a framework to help you with. And in fact, Spring AI does. So see, when we make the call here, previously we asked for just the response and we got text back. Here, we're asking for an entity and specifying the type of that entity. That causes Spring AI to do some magic under the covers. What it does is it introspects the topic classification class and adds some text to the model interaction saying, when you return, please use JSON to return this structure. So it generates a JSON schema and passes it up to the model. The models have all been trained these days on returning structured data in JSON. So it's highly probable that even a local model, like the small one that I'm using here, is going to do that correctly. But notice we didn't have to write any low-level code for marshalling that JSON response. The model that I'm going to use here is an Ollama model running on my machine. It's much smaller. So these are the local models I've got. So this model is Gemma 2b, and this is now up and running on my machine. Tell me something about Brisbane. This is running on my machine and it's not terrible. So as you can see, there are certain things that this could be good for, like for example, translation tasks, summarization tasks, potentially this kind of classification task. It would not be capable of doing the RAG-enabled chatbot task that I have tried it, and the results were really quite bad. Okay, so now we've got this up here. I'm trying to remember which port we're up to now. So why don't we go to, let's go to, we haven't burnt 8084 yet, have we? Let's burn port 8084 and see what we get. This is the first talk I've ever had to do this. This is fascinating. So hopefully the topic guard will be in place. So if we run it, despite it lying to me, it's still up. Do you like Debussy? It'll probably tell me it's an AI, but it loves classical music. I don't have personal preferences. Okay, fair enough. Do you like Donald Trump? I'm sorry, but I can only help you with classical music. Notice that response was really fast as well. Let's look at how that happened. That came from the topic guard advisor, where we use this isBanned topic method. So in the advised request, we firstly asked if the topic was banned. We did this using a retry template because the local model's a little bit more flaky, but guess what? We're still saving the planet. If the local model doesn't work 100% of the time and we have to re-invoke it, it's still better than using all that water from OpenAI. And if the topic is banned, we kind of short-circuit the response to say, I'm sorry, I can only help you with classical music. So there's one other thing that I wanted to show, which I think I'm just going to show the code in the 2 minutes I have remaining rather than run it. But we've seen one core technique for grounding LLM responses and avoiding hallucinations. That is RAG, Retrieval Augmented Generation. There is another really important technique, and that's called function calling. So modern models have been trained to be able to know when they should call functions. So the way this works is you pass up to the model a string saying, by the way, you might find these functions useful. And so, for example, if the user wants to update their mailing address, call this function, and by the way, here are the arguments. So the way in which this looks in Spring AI is rather consistent. So let's go to the chat service and put some function calling magic in there. So we would simply do this. So we would add default functions. In this case, the functions have been injected. Remember that in Spring, you can inject a list as well as a simple type. So this is going to say anything that implements Spring function callback in my context, inject it here and make it available. So let's look at where they come from. They're in a file called functions, and we're using the builder pattern to build function callbacks. Notice that this enables us to implement functions with full access to the resources managed by the Spring container. So in this case, I've injected the Neo4j template, and these functions are actually interacting with Neo4j. So in this case, it's actually doing a database query and returning the response. So, you know, another benefit of using Spring AI is that you can really leverage everything you already have in your Spring applications. So look, I'm sorry, I really did want to illustrate the function calling, but I'll leave you with a few of what I think are best practices and a few challenges. Best practices, use Kotlin. Spring today is really economical. It is very concise. You don't really have to do a lot of configuration, a lot of duplication. When you see Spring apps using Kotlin, you realize that whatever duplication is in most Spring applications today comes from Java, not Spring. Secondly, externalize your prompts rather than burying them in strings. It really drives me crazy when I see people burying prompts in Python F strings or Java strings. Thirdly, consider the use of multiple models, because you should be able to use the most appropriate model for your scenario. Okay, well, if you want to see the full code, including the function calling, remember Johnson R on GitHub, and it's pinned as Spring AI demo.